Here we explain why the infinite decimal expansion 0.9999 and so on is equal to 1. And we will use our understanding of sequences to do this. First, let us try to understand what we actually mean by a number with an infinite decimal expansion. Let's think of a general number, a, and suppose the digits to the left of the decimal point can be represented as a sub 0, and it always can be. And the first digit to the right of the decimal point is a sub 1. The digit to the right of a sub 1 is a sub 2. And the digit to the right of a sub 2 is a sub 3. And we do this infinitely many times. And this is how we define a number a with an infinitely long decimal expansion. We will notice that a seems to be similar to the limit of the following sequence as n approaches infinity. Let's call the sequence, the terms of the sequence, alpha. So alpha sub 1, let's suppose that is a sub 0 that a sub 1. Alpha sub 2 is a sub 0 that a sub 1, a sub 2, and alpha sub n equals a sub 0, a sub 1, a sub 2, up until a sub n. And we define a by definition. What we actually mean by a number a with an infinitely long decimal expansion, we define it to be as follows. It is the limit as n approaches infinity of the sequence defined by the alphas here. So this is alpha sub n. So this is what we mean by this number. Now, we will take a closer look at the number 0.99999. And so we have an alpha that is 0.999, and vinculum, that is to represent that it is repeating infinitely many times. We can see that the terms of the sequence will be as follows. Alpha sub 1 is 0.9, alpha sub 2, 0.99, and alpha sub n will be 0.99 with n terms after the decimal point. And because we know that by definition, a equals the limit and approaches infinity of alpha n, we know this from the definition, we just need to find a sequence with the following terms. And we can see that, for example, the first term is actually equal to 1 minus 1 over 10. The second term is 1 minus 1 over 100. And the nth term is actually 1 minus 1 over 10 to the nth. So these are the terms of our sequence alpha. And so we can just substitute it here. And we obtain the following limit. And this is not very hard to evaluate if we know the arithmetic operations and limits, which we apply here. Then we recall that this limit is actually 0, and that this limit is actually just 1. And so we have the following expression, that a is equal to 1. And also we began with the following definition, that a is equal to .999 vinculum.